Question 25. So for question 25, question says, well, verify that the indicated function is a solution of a differential equation. So check to see if y equals to e raised to 3x times the integral of 1 to x of e to negative 3t divided by t dt is the solution of the differential equation x dy dx minus 3xy equals to 1. Very well. So this is the possible solution that we have, and we need to verify that if it satisfies this equation. We have left-hand side, we have right-hand side. For the left-hand side, for the right-hand side, we need to plug this y and its derivative into the left-hand side, and right-hand side is just a constant. Check to see they're equal to each other or not. So x is x. We need to find the derivative of y. So y is equal to e to 3x times the integral, negative 3t divided by t dt. So first of all, note that you have the product of two quantities, e to 3x times this integral. So it means that you have to apply the product rule. So to apply the product rule, y prime is equal to the derivative of the first quantity, e to 3x, the derivative, times the integral 1 to x e to negative 3t divided by t dt, plus we copy down e to 3x and the derivative of this integral, negative 3t divided by t dt. So the derivative of e to 3x is just using the chain rule, 3 e to 3x multiplied by this integral. Plus e to 3t, and the derivative of this integral is equal to e to negative 3x divided by x. And this is x. So we found the derivative. What's next? In the next step, we have to plug that in to this equation. X times the derivative. 3 e to 3x times the integral 1 to x e to negative 3t divided by t dt, plus e to 3x e to negative 3x divided by x, and let us close up the parentheses, minus 3xy, minus 3x and y. So let me erase this part of the board. And rewrite this here on the other side. So you get 3x times y, which is e to 3x. You're still on the left-hand side of the equation. E to 3x times the integral 1 to x e to negative 3t divided by t dt. is this guy equals to 1? 1 is on the right-hand side of the equation. Very well. So if you distribute x into parentheses, you get 3x e to 3x integral 1 to x e to negative 3t divided by t dt plus x and x, they cancel out each other, e to 3x minus 3x, and then here you get negative 3x e to 3x integral 1 to x e to negative 3t divided by t dt. Well, here you have e to power 0, which is equal to 1. And as you can see, these two quantities, they are opposite of each other. So you're left with 0 plus 1, which is 1. 1 and 1 are equal to each other. So let me rewrite this. Here for you, product rule. Y prime is 3 e to 3x integral 1 to x e to negative 3t divided by t dt plus e to 3x times the derivative of the integral is e to negative 3x divided by x in this case. So we just verified that this crazy looking function is a solution of this differential equation. Let's take a look at question 30. Well, question 30 says, show that the piecewise defined function y equals to square root of 25 minus x squared if x is bounded between negative 5 and 5, and negative square root of 25 minus x squared if this is 0. If x is bounded between 0 and 5, is not a solution of the differential equation y prime equals to negative x divided by y on interval I negative 5 to 5. There we go. First of all, remember that we need to check the continuity before going forward. This guy is a piecewise defined function. This function is a piecewise defined function. So before moving along and checking that if the derivative is equal to negative x over y, we need to check the continuity of this function before we move on and check the substitution for the ODE. We need to check the continuity of y, which is defined this way for us, square root of 25 minus x squared. X is bounded between negative 5 and 0 on this interval, and if we change the interval, it's going to be the lower half of the circle. Negative square root of 25 minus x squared. But is this function continuous? Well, so around 0, note that the limit of square root of 25 minus x squared as x approaches to 0 from left-hand side is equal to, well, square root of 25, which is 5. The limit of negative square root of 25 minus x squared as we are approaching to 0 from right-hand side, 0 from right-hand side is defined on the second part of the function, is equal to negative square root of 25, which is negative 5. Since these two are not equal to each other, we don't have continuity. We don't have continuity at 0. So we cannot move forward.